Okay, what else? Now, you know that you can dereference pointers and take addresses of pointers. Those operators are overloadable. You can define, you can define what you want to do when someone wants to overload an operator. The strange thing is that if we redefine an operator such as this, like point pt3 equals pt1 plus pt2, whatever that means, right? If we overloaded operator plus, if we found a way to overload operator plus, and we could produce another point by adding those 2 points somehow to produce another point as a result of that. On the C++ compiler side, there's absolutely no way to control what you do here. You could be doing something completely unrelated, completely illogical, and unintuitive. It's your choice. So obviously, the whole notion of operator overloading comes with certain responsibility, so that when you overload operators, you do it in the most straightforward manner, so that everyone can, including you, can understand what it all means. Because you shouldn't be doing something obscure with operator overloading, and if it's something obscure, you should probably just use a normal function for that type of work. But if it's something like this, and it makes total sense to anyone who is involved in whatever manner we use pointers, and everybody appreciates this, that's the way to go, and not making a function call. So now, very interesting thing that we can overload an assignment operator. So assignment between objects can be overloaded, and it's as critical as copy constructors, as adding destructors to our classes, because sometimes, as you know, there could be shallow copy as a result of copying things over, and sometimes it's not something that we want. Typically, again, if you discovered a need for a copy constructor in your class, then you probably need a destructor, and you probably need an assignment operator also defined for your class. So we'll see some examples of that. Okay, we can, in general, when we talk about operators, the operators can be unary operators and binary operators. So, for example, if I say integer x equals 1, 2, 3, right, and then I say integer y equals minus x, the unary minus is the unary operator because it requires only one operand, right? So it takes this operand, computes internally the 2's complement of this value, and the result of this is y. And also, unary minus doesn't modify x, it only computes the result of this expression, and the result is stored in another variable. Okay. On the other hand, we could say x minus 5. In this case, the subtraction arithmetic action is expressed through a binary minus operator, which is minus recycled, but it's a different operator, right? So this operator and this operator are two different operators. So these are unary operators, and this is a binary operator. So the binary operator needs two operands, whereas unary operator needs only one. Another example of unary operator would be when we create a pointer, right? So we say take address of y, for example, right? So address operator also requires only one operand. Therefore, this is an unary operator. So just by looking at the description of the operator and how it's defined, you can instantly say whether it's unary or binary operator. There is also the so-called ternary operator, which is sort of unique in its own way, and what it looks like is this. We can say Boolean. Actually, I can use it in the arithmetic expression. Integer z equals condition x greater than 100, for example. If it's greater than 100, assume 1, otherwise assume 0, right? So this is the ternary example of a ternary operator, which basically contains 3 parts: the condition to be analyzed, the result of the condition, the result of this entire expression in case if the condition is true, it's this part, and the result of this expression that should be assumed in case if the result of this condition is false. It's called arithmetic if because if I produce 1 and 0 out of this entire thing, then I can add it to y, right? And so this will be, the result here will be the z will take, based on this condition, will take 1 or 0 plus y, right? So all this is sort of like an instant condition check, and if true, then this, otherwise that. So this is called ternary operator because, or tertiary. The wording is kind of crazy. So because it has those 3 parts. However, this operator is you cannot overload this operator in C++, and so that's why we really don't mention it here on the slide. We just say, okay, operators can be unary and binary. Soon enough, when we see the concrete examples of overloaded operators, we will find out that operators can be overloaded as member functions or non-member functions. And some of the operators can be overloaded only as member functions. So there are some rules that comes with definition of these operators. For our discussion here today, what I'd like to use, instead of using this unmanageable in a way point that we don't have a drawing, or we don't have any way to display the functional part of it, so I kind of scratched this idea of a point and instead use something called rational. In fact, let me do this. I'll just kind of sort of like reduce this to empty program, and we'll go ahead and create a normal implementation file and the header file for this rational thing. So here we go. We have a project. We have a project here. Where is it residing? Copy full path. I'm just trying to understand where I have it. C255 overloading. Okay, C255. It's on the D drive. That's why I couldn't find it. 255 overloading. So this is my project directory. So I'll just create a couple of brand new files. One will be text document, which is rational.h, right? A rational number.h, and then another one. Another text document will be rational.cpp, the implementation file for the rational concept. Okay, so then implementation file.cpp has to be included in the project, make it part of the project configuration. So we need to add existing item, which is called rational.cpp, to our project. And when we open it, of course it's empty, but the typical thing that we would expect, include rational.h to begin with, and then do some work in here. Okay, so we have these files in rational.h. If I open this, it's empty as well, but we can then say if not defined, rational h included, something like that, then define this thing, rational dot h included, define it. I don't know why I'm using space in here. So we define the header guards right away, so our header is safe to use and properly, configured to begin with. So we have a good picture of everything right now. And here inside we're going to have class named rational. Okay, so this will be the beginning and ending of this class. And inside this class we will have the two parts here, which we specify as the rational number, of course, is representing a fraction. But as you know, floating point data types such as float or double, essentially impose a certain level of precision that you have to accept and deal with, and deal with imperfection of that precision. So the alternative is to create this rational number class and actually manage fraction internally as the numerator and denominator for the most part. So let's save this section.